Welcome to Rehash.
Hey everybody, welcome back to Rehash, a Web3 podcast. I'm your host, Diana Chen, and today we're speaking with Jimmy Chang, co-founder of Catalyst, about what modular blockchains can enable for people, the data availability problem, running experiments in Web3, and my goal for us in this conversation is to break down all of these highly technical concepts into an understandable way for all of our non-technical listeners. Before founding Catalyst, Jimmy led experiments at Aave and was a product manager at Unstoppable Domains and Ripple. Jimmy was nominated by Diana Chen, me, and voted onto the podcast by Paris Rosati, Justin Conley, Nitch, Chase Chapman, Christina Beltramini, David Phelps, Stefan Delaveau, Fifth World Zach, and Scott Moore. Before we dive into our conversation, here's a quick word from the Web3 projects that helped make this season possible.
Social media wasn't designed for ads and algorithms. It was made for people. And at Lens Protocol, we're putting people back in control. We're not looking for users' data. We're here to build a community of collaborators, builders, artists, and dreamers ready to unlock a new world of social media. This isn't just an app. It's a flourishing ecosystem of platforms and experiences owned and operated by the developers and creators who are bringing it to life. In the Lensverse, you don't just own your content. You own everything. Your data, your connections, the value you bring to the table, it all stays in your possession, exactly where it should be. As a creator, the Lens ecosystem offers a new set of tools for connecting with your audience. Your data is truly portable and belongs to you. Post once and distribute everywhere in the Lensverse. You can even take your followers with you from app to app. As a developer, you can skip right past building the base layers and scaling your users by plugging your new app directly into Lens's existing infrastructure and community. So whether you create with a brush or a camera, sound waves or lines of code, it's time you got your due. Come create the future of social media with us on Lens Protocol. Lens is the last social media handle you'll ever need.
Have you seen how epic Ambire Wallet is?
How epic it is?
Yeah, cue the music. Ambire is a Web3 wallet that makes crypto self-custody easy and secure for everyone. Instead of relying on clunky seed phrases, you can create an account with the hardware wallet or username and password, secure it with two-factor authentication, and regain access with Ambire's cloud recovery. Need to pay out some contributors or execute a bunch of trades? No problem, Chief. Queue up as many transactions as you want, and when you're ready, execute the entire batch at the same time, paying gas only once. You can even prepay for gas with stablecoins or Ambire's native wallet token, which will get you some cash back. Without ever leaving the Ambire interface, you can manage assets from over a dozen chains, safely migrate them with Ambire's built-in bridge, and seamlessly interact with dApps like Uniswap, Aave, and Snapshot, all within the same transaction. Plus, Ambire is constantly growing their dApp catalog with trusted partners and collaborating with builders who want to establish the new standard for smart contract wallets. So, pretty epic, huh?
Yeah, I already know all that though. I've had an Ambire wallet for months.
And you didn't tell me?
You never asked.
To get involved and truly own your assets, go to ambire.com.
How was your day?
Bad.
What happened?
I bought some NFTs and then they just disappeared.
Sounds like your NFT creator should have used NFT.storage.
NFT. What?
NFT.storage. Come on, I'll show you. With NFT.storage, anyone can easily upload their NFT data to a decentralized and reliable storage network, completely for free.
Wow! How does it work?
Well, instead of relying on centralized and impermanent storage solutions, NFT.storage uploads your files to IPFS and Filecoin. These are powerful peer-to-peer networks that are made for the decentralized web. Thanks to IPFS's unique storage system, you can be confident that once your files are uploaded, they'll be accessible from anywhere in the world for as long as you'd like. They're already trusted by some of the biggest names in Web3, like OpenSea, Magic Eden, and Rarible. By adding files to these networks for free, NFT.storage is helping to turn proper NFT data management into a public good. This will ensure that NFTs will remain accessible and secure in the long run, so you won't get rugged again.
Gee, so I just upload my files and NFT.storage will take care of the rest?
Now you're getting it! Go to NFT.storage today to upload some NFT data of your own, for free. And be sure to follow nft.storage on Twitter at nft.dot.storage.
So without further ado, Jimmy Chang, welcome to the podcast. How are you?
I'm good. Thanks for having me.
So I want to start off, and I know this is the challenge for you today is going to be breaking down a lot of these highly technical concepts into easy to understand ways for non-technical people, but we're going to do our best because I do think that a lot of this is really important for people to know today. Anybody who's doing anything in Web3, whether they're, in a dev capacity or not. So to start off with kind of just the basics, can you explain in the simplest terms, what is a blockchain?
Wow. Okay. It's been a long time since I've thought about what a blockchain is. Funny enough, there are actually like new projects out that are not blockchains. A lot of them are called DAGs, which are essentially it's like a 2D blockchain basically, but that's like a digression. But I guess like when people think of...
Can you briefly explain what that is? I've actually never heard of that.
Instead of like a blockchain flowing like sequentially, so it's like you have a block and then you have like another block and then like another block, right? It's actually like bidirectional. So there's like vectors that point to like where this data structure is actually going to follow, right? So there's basically like two tails of like a block essentially, but they're not called blocks. I forget what they're called. So it becomes like a 2D blockchain of sorts for like, throughput and efficiency gains.
Wow. What are those used for?
I think like the most popular DAG right now is like SWI. So it's like the Facebook Libra fork along with Aptos. Essentially, like it's just data structures being leveraged for some form of like high throughput transaction processing. And then there's been other DAGs that kind of been implemented. I think SWI is like a full stack DAG, right? So it's like everything's a DAG, even including the mempool, as well as the consensus. Whereas there's been like other DAG light implementations, like Phantom, for example, which has been like a quasi DAG.
Okay, yeah. So I think a lot of people, when they think of SWI or even Phantom, they think of it as just the same as any other blockchain, like Ethereum or Solana or anything. So like from a practical standpoint, from what the user can see, how would a user tell the difference between a DAG and a blockchain?
I mean, like, effectively, there's no difference from like a user perspective. They're made to like process the same type of interactions, right? So it's like you have a transaction or you have some sort of like change of state. And like, a DAG is basically just like processing a different way. But sorry, to answer your original question of what a blockchain is, and I think it's like a good discussion because people are like, wait, like this thing that I thought was a blockchain is actually not a blockchain. But like colloquially, it is a blockchain, right? Or it's just like crypto or Web3 or what have you. A blockchain is basically like some form of like data processing structure in which essentially a lot of different actors can agree on the state or the validity of a state of something through some sort of like consensus mechanism, right? And so the way they do that is through essentially building a chain of blocks, right? And so it's like you have one block that has like all these different transactions and there's consensus and agreement on what is the ordering of those transactions and the validity of those transactions based on kind of like the protocol's rules. So things like, oh, like you can't spend money that you don't have, right? Or it's like you can't set a transaction ahead of another transaction that you have queued up, right? Something that, we call the nonce in Ethereum land. Because like there's kind of like a finite amount of scope that all these different machines need to be able to validate and verify like the validity of, you need to kind of like bound the data limit of these blocks, right? And so it's like these kind of scope mechanisms become a block, right? I think in Ethereum, it's kind of a varying gas limit, but we call it like the gas limit or the block size. In Bitcoin, like there used to be like a specific number of a block size, and then, they recently increased it using something called segregated witness. But yeah, so like you have these blocks, and then like once you verify this block, you're like, okay, like that's done, right? That is a block, right? And then you like add on top of it and you add more blocks. So it becomes like more manageable for all these machines or this distributed network of machines to be able to verify the right transactions in a timely manner.
So blocks are determined by time, right? And then transactions that happen at a certain time can be on the same block.
Not necessarily time per se, because, and again, it's based on the blockchain's kind of core rules that the protocol follows, or rather, more technically, like the consensus mechanism. So it's less about like time, although there is kind of like a range of time that people can kind of expect a block to be created or a block to be finalized. But there can kind of be outliers that kind of go outside of that range. But it's more of a function of like what actions have been performed, right? And like in a timely manner, you can expect it to be like a couple seconds or what have you. But in the case of like an outlier, like let's say someone or an entity creating a block goes down, or maybe there's like some latency in the network or what have you, it could actually be longer than that.
And then who are the people or entities creating these blocks or even verifying transactions, doing all of these things that you talked about behind the scenes?
Yeah, so it definitely varies, I would say, based on the blockchain. But I think broadly, there's like a centralizing force, right, that kind of gravitates towards these organizations that follow a power law. And so for Ethereum, it's kind of these entities that have the majority of stake or have sizable stakes in the network. And so people like Coinbase or Lido or Binance, for example, right, they take on the stake of their users. And stake just means like people who hold ETH and they want to essentially use it to secure the network, and then they get a reward from it in order to do so, right? And so these people hold ETH and they're delegating it to these institutions like Coinbase or Binance or Lido for the pursuit of yield, right, or the expectation of yield. And so these entities can now like propose blocks and attest to blocks on these users' behalf. And then, they take like a cut of portion for basically that service, right? And so it becomes like a centralizing force where like it's basically like institutions that people know. Like when you look at Bitcoin or you look at like pre-merge Ethereum, right? Like proof of work Ethereum, it's a similar concept. It's like, okay, there's like these mining pools and they're all kind of like solving these really kind of computationally intensive problems in order to actually verify a block or win kind of the right to build and propose a block. That ultimately becomes like very expensive and very computationally intensive. And so only like a really large organization can really reap the benefits from it.
Gotcha. And this is better than a centralized financial institution because even though, like you said, this is still kind of like centralized forces, because no singular entity or person can control the entire blockchain.
Yes. So, I mean, I think there's a couple ways you can slice that. Like better is definitely a loaded word. Because I feel like once you like peer underneath the curtain of like how some of this infrastructure works, you're like, oh, like what's going on here, right? But it is better in the sense of kind of what you were talking about. It's like it's more distributed, right? It's not one single entity. It's kind of like an oligopoly of sorts, but none of them are really colluding, and there's not really incentives for them to collude together and do things that we've seen kind of cartels or oligopolies do, like price gouging. And also, like, I think broadly the protocol enforces a lot of rules that are immutable, right? And like unbreakable. An address can't just take the money from your wallet, right? Like a user needs to sign for that specific transaction to occur. And so even in the case of like, okay, like there's some sort of a takedown in the network or kind of a denial of service attack, your funds are still safe. It's just a matter of like when they come back online, right? Like you can never have your funds taken away. It's like a liveness guarantee, essentially. It's like you can't really do anything with it right now until it comes back online.
Gotcha. Okay. I think that provides a pretty good primer for what blockchains are. So something that people have been talking about a lot recently is modular blockchains. Can you explain what a modular blockchain is?
Sure. Yeah. So a modular blockchain is kind of like a evolution of mental model of what a blockchain is. And I think it came around 2 years ago, maybe a little bit over 2 years ago. Well, the terminology came like over 2 years ago, kind of, championed by Celestia, mainly from a narrative building perspective. Celestia is a data availability layer project, and then Fuel as well has kind of been championing that narrative. But it's been kind of around for a while now, like I want to say all the way since like 2016, 2017, of the concept of like, okay, like how do we have some form of like off-chain or like little blockchain or like off-chain kind of enclave or environment that allows us to scale the things that blockchains are not very good at, right? And in that case, like it used to be called like Plasma as like a side chain, and eventually became, Rollup, which is, I think a term that many people are familiar with now. So that's kind of like the context behind it. But to answer your question, sorry, I'm not good at answering questions directly. A modular blockchain is basically taking like all the jobs that a quote monolithic blockchain does, something like, pre-merge Ethereum, and essentially like breaks that down to different component pieces, right? And so there's a lot of discussion on like what those different pieces are, but broadly there are four things. So it's execution, it's transaction ordering, settlement, and then data availability. And then like there's different solutions that are like trying to break those four things apart, or kind of like breaking those four things into two separate things as a form of like optimization, right? So it's kind of like when you go to like a bodega and you're like, oh, like I would like a sandwich, please, right? And they're like, okay, like here's your sandwich. And it's just like this, like block of bread, right? And you're like, I don't even know what's in this, but I'm gonna eat it. And you're like, oh, I ate it. It has like onions in here. Like not a huge fan of onions, right? But imagine you go to a bodega and you're like, hey, like, can I have the sandwich? By the way, no onions. And can you add in jalapenos, right? And they'd be like, sure. And you're like, okay, that's awesome. Like, that's the same concept as like modular blockchains. You're like, okay, I'm just like swapping things out based on like what I need. And that becomes better, I guess, as a result. It's like a more optimized system.
So it's almost like you're taking the different Lego pieces and building your own like figurine, your own blockchain.
Yeah. But, more like a sandwich.
I also hate onions too, so I like that analogy. Okay.
I like onions. I was just being illustrative.
Oh, well. Can you explain the four different, I guess, factors or parts that you highlighted: execution, transaction ordering, settlement, and data availability, and what each of those things means? And I guess like from somebody's perspective who is trying to maybe create their own modular blockchain, how they would think about what they want out of each of those four pieces.
Yeah, definitely. So execution is kind of what I think most people think about when they think about blockchains, right? It's like actually having, business logic that lives in some sort of virtual machine. And when you interact with that business logic and, you kind of like send transactions to it, something like executes, right? So like things like DeFi or NFTs like are kind of like living within that layer. And they do things like they change the logic, or like they run through the logic, and that changes the state of like something, right? So it's like, oh, I send money here, my state changed from like 500 USD to like 0 USD, and some state change in another place. It's like, oh, now there's like, a cartoon monkey that's like in the blockchain or something. And so that's kind of like execution broadly. And so there's a lot of different design principles that you can have from an execution environment, and a lot of different kind of solutions that are being executed and innovated on the execution layer. So this is where, I think popular virtual machines become kind of like within the vernacular of the space. So it's like, oh, like EVM, right? Ethereum virtual machine. That's something that people understand. It's running the virtual machine that, Ethereum runs. It uses kind of a EVM friendly languages that people are familiar with, like Solidity. And there's like all these different VMs that are like kind of optimized for different things. And so you can do things like parallel execution, right? Which like that's what Move does, and that's what Fuel VM does. And so it allows for kind of higher throughput in transactions. So it's like basically just like trying to like soup up like a blockchain, right? You're trying to move like a bunch of transactions through it, and you want to like efficiently use computational resources in order to do so. Sorry, that was way too long of an answer, but that's execution. Transaction ordering is exactly what it sounds like. It's like when like requests come in on the execution layer, like how do you actually like order those transactions and then like feed that into like the virtual machine? The third piece is data availability. And so data availability is kind of interesting. So it's basically like storing all of the transaction data that is being fed into the execution layer. And so you can kind of see how like data availability and transaction ordering like work really well together, right? Transaction ordering is like how do you order the transactions, and then data availability is like storing kind of like the raw data of these transactions. And becomes really important because you need kind of a place in which like people or entities are able to check the veracity and the legitimacy and honestly just like the existence of this data so that they can map it to the execution layer, right? Sorry, that's kind of abstract, but the last piece is like settlement. And so settlement is kind of like contentious, I would say, because a lot of people say you don't really need settlement. And if you look at like all of, Vitalik's posts, I don't think he's ever even used the word settlement layer. He's used the word security layer. And so it's some concept of like dispute resolution. It was like the best way I saw kind of described it, where it's like, okay, like it's kind of like a layer where you're either doing like some form of verification of what happened on the execution layer, That's where something called like a fraud proof comes in, right? So you do like dispute resolution if something is wrong, or you do like a validity proof, right, for like a ZK rollup. And then you also like, that's where all kind of like the canonical bridges live. And so like if you ever want to bridge from like, some sort of execution layer, i.e. a rollup, into like a settlement layer, like you're probably just gonna use the bridge on the settlement layer as opposed to the one on the rollup. Sorry, that's also kind of abstract. But it's really important to do that because, well, it's really important to have a data availability layer for a settlement layer, because if you have a settlement layer and you're trying to verify like the validity of what's been happening on an execution layer, you actually can't do that without like the data availability layer. You're trying to say like, hey, like this was wrong, but then you try to go, it's like basically saying like you're taking like a Scantron test, right? Like a standardized test. And you're like, oh, like 2 + 2. And you're like, okay, that equals, and you bubble in 5, right? And then someone goes, it's like, wait, that's wrong. It's like, well, why is it wrong? And they're like, oh, well, I need to go back to your scratch notes. I need to see you doing those scratch notes. And you're like, well, I don't have the scratch notes anymore. Sorry. And they're like, they're like, I know this is wrong, but I can't convince other people that it's wrong. Right. So like, that's kind of like the analogy that I would use.
Gotcha. So when people talk about the data availability problem, are they talking about the problem with having enough room to store all of this data on chain?
I'm actually not familiar with the data availability problem.
That's a thing, though, right?
What
I
is the
didn't just
data
make that up.
availability problem?
Oh, I don't know. I've just heard people talk about it, I thought, but maybe there isn't a problem.
I think there's like a few problems. Like one of them is like data availability is like kind of expensive if you're using something like Ethereum as a data availability layer. And that's because like data availability is like pure storage, and like storing things on Ethereum is like very expensive, right? And so there's all these like EIPs that are coming out, right? Ethereum improvement proposals. They're like, oh, like we need to like lower the cost of storage, right? Or like we need to like create a new data type for this kind of information because it's not technically storage, right? And so they're trying to like make it cheaper, which is helpful. And I think the problem broadly is like when you're trying to compress data, there's kind of like an asymptote that you hit, right? It's like you can't really compress it anymore and it's still expensive. And you're like, okay, like what's really the efficiency gain here? And so when you think about the concept of like, sorry, this is probably way too deep, but it's like recursive, like zero knowledge rollups. So it's like there's it's a ZK rollup that like posts to Ethereum, right? So it's like on Ethereum. And there's a ZK rollup on top of that ZK rollup. So it's like recursive, right? So the people call it like an L3 or a recursive ZK rollup. So when you're using a snark, you can compress computation to like this like kind of fixed or somewhat fixed proof size. But the data availability cannot be compressed like in the same way, right? So like when you're doing like a recursive ZK rollup, you still have like a linearly increasing amount of data that you need to post into Ethereum, which is very expensive. And so I guess that's like the data availability problem. There's another problem where it was like, oh, how do you even like make the data live, right? Because there'd be a point where it's like, oh, like I just did a validity proof. Here's like the data availability, and like people are trying to check against it, but like they can't find the data. They're like, wait, like how do I know if this is right? Like there's no data, right? And so that's like another problem, I guess.
Yeah. What are some solutions out there that you've seen to this problem that help us store data on chain in a cheaper way?
Well, like one thing is like making like a dedicated data availability blockchain, essentially. And so that's like what Celestia is doing. That's what EigenLayer/EigenDA is doing. Polygon Avail is doing as well. They're like, oh, it's like a blockchain, but like we're like stripping away a lot of like things about it. So it becomes like really good at just like storing data. And so it's effectively just kind of like a database for like all these like raw data to live. And there's like a liveness property to it. So it's like, oh, like we can like call data after like, 24 hours or something because no one really needs it anymore. And that becomes like really cheap, right? Because like you have these like giga big like block sizes and, you have kind of really cheap storage costs and there's no, you're kind of stripping away other pieces, right? There's like no virtual machine, there's like no transaction ordering / consensus, like et cetera. And so it just becomes like this place where you post things and it becomes quite cheaper.
Interesting. Okay, I was going to ask if they would have to be like EVM compatible or compatible with whatever virtual machine they're offering storage capabilities on. But you're saying it's just it's like a completely separate thing.
Yeah, definitely. It's literally like a place where you're like, here's all the data, it's like a Google Drive.
Okay. Okay.
Yeah.
That's easier to wrap my head around. So something that you said at your talk in East Denver, which I did watch on YouTube and understood very little of, is you said that in the future, you believe there will be millions of blockchains. Help us wrap our minds around that. Maybe like just set the stage too with how many blockchains are there today? Do you know?
Yeah, I think there's like 900.
Okay, there's 900 blockchains today. You think there's going to be millions in the future. 900 already sounds like a high number to me because I could probably only list like 5 to 10 off the top of my head.
No, you could list more.
Okay,
We should
but
do it
point
right now.
No, let's not. But point being, most people are only familiar with a really small percentage of the total number of blockchains today. What are all those blockchains out there doing or being used for? Like, are they being used, or do they simply exist and they have no users?
Well, I don't know if they have users, but they have like supporters, I would say, just based on like crypto economics and incentive mechanisms and stuff like that. But a lot of them are like ghost chains. Like they don't really have any usage, right? I think a lot of them came during like the ICO days where it was like everything was like a blockchain. Well, it's kind of funny where like how like things become very cyclical. But like, in like the ICO days, like everyone was like, oh, like everything can be a blockchain. It's like, oh, like Uber can be a blockchain, right? It's like you get paid in like a token every time you do a ride, or it's like Wi-Fi can be a blockchain, right? It's like, oh, like if you share your Wi-Fi with someone, they can like pay you for that or something, right? And so like everyone was just like making these blockchains. And eventually like, 6 years later, you're like, yeah, I don't really know if that needs to be a blockchain. Right? Or there doesn't need to be like a monolithic blockchain necessarily. And then like during like 2020, people are like, nah, I'm good. Like I'm just gonna like be on Ethereum, right? And then all these like other blockchains kind of like lost a lot of usage. They're probably still around, but lost a lot of usage for Ethereum. And now we're kind of like coming back. We're like, oh wait, like everything should be a blockchain, right? But instead of being like a like monolithic blockchain, like like people like bootstrapping a validator set and like having to like have security to secure the network and all this different infrastructure, it's now becoming like a modular chain, right? So now it's like, oh, like I can just like spin up a blockchain like literally at the click of a button, right? There's like all these kind of new projects out right now that are kind of enabling that. So it's like, oh, I click a button. It's like, oh no, I double clicked it accidentally. Now I have 2 blockchains, right? Like that's how easy it is to make a blockchain. And you can like configure it to like all sorts of different parameters that you want in order to make your blockchain really good at the one thing that you want it to be really good for, right? So it's like, oh, a really like gigafast, like high throughput blockchain for traders, right? And so it's like high frequency traders can be like looking at all their 6 screens and like doing like crazy trades and like stuff like that. Or it'd be like, oh, like a really, really slow blockchain for like high value transactions, right? And so it's like a Bitcoin-esque thing, or it's like, oh, like a blockchain that we don't really care about kind of what the financial pieces of it are. Like we just want it to be easy to use, and that's for like Web3 social, right? So it's
why would all of these things need to be separate blockchains versus just like being an app?
Because when you're an app on like a shared compute layer, or like a monolithic blockchain, I guess, like you have to inherit a lot of overhead that you don't necessarily want, or like that kind of makes it very suboptimal for your application to run on it, right? And so it's like you literally cannot run a full on-chain video game on Ethereum, right? It's like you like move one square and you're like, mine, it's like transaction processing, and you're like, okay, like who would play that game? It'd also be like super expensive. It'd be like $5 to move a square in like a Pokemon-esque game. So you're like, why would I do that, right? Whereas like you can do it entirely on chain if it's like, using Narwhal plus Bull Shark, DAG, parallel execution, blah, 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 right? And so that's kind of like the net of it. It's like there's rules that you don't want to follow that you need to follow in Ethereum, right? And so like one of them is like, oh, like there's no native account abstraction on Ethereum, right? Which means like there's not like a lot of like programmability on the transactions that we can have on Ethereum, right? So things like, oh, like I would like to mint this NFT if the gas price is less than this, right? Or something like that. Or it's like, oh, if the gas price spikes increase it because I need this and I really want this NFT, right? You can't do that in Ethereum. And you can do that if you bake it into like the core layer of like a new blockchain, essentially.
Gotcha. Okay, so I know you talked about in a recent article you wrote how these app-specific chains will get built. And your thesis was that they're going to get built through RaaS, Rollups as a Service. So kind of a spin on SaaS. And I know you've already mentioned Rollups a little bit, but could you just quickly, for people listening who don't know what Rollups are, like explain what a rollup is and then what this RaaS thesis of yours is?
Yeah, so like we'll start. So a rollup is like exactly like every time I say like execution layer of like a modular blockchain, I mean like a rollup, right? I mean rollups can technically also be settlement, but like we're not talking about that today. Sorry, Diana, we're not doing that.
I'm super bummed out. No idea what that is.
You don't want to talk about settlement rollups? No, I don't think many people do. So like again, it's like some form of like modularized like blockchain that's specialized to do just execution, and things like data availability and transaction ordering and a settlement is kind of outsourced to other blockchains essentially. And it's good because then it becomes like, you know, really cheap to run very computationally intensive programs like a video game, for example, or, you know, ChatGPT. So that's like basically what a rollup is. And so the good thing about a rollup, and this kind of is a good segue to RaaS, is like you actually like have a lot less infrastructure overhead in order to build a rollup, because you are kind of like outsourcing a lot of stuff like, you know, block verification, data availability, stuff like that into other entities or other layers. And so it becomes like really or much easier to run a rollup, right? And so even kind of like the V1 rollups that we've seen, right? Like Arbitrum, One, and now Nitro, and then Optimism. I forget what it's called. I think it's just called Optimism. Optimism mainnet. Like they're still somewhat hard to run. You know, like there's a lot of infrastructure required to like run these sequencers, and you know, I think a lot of them are still innovating on fraud proofs. But you can kind of like see where you're like the V2 version of that is like hyper optimizing like all those parts of the stack and just like kind of offering out of the shelf, right? And it becomes so easy that it's like it's a service, right? And so it's anywhere from like, hey, here's like this SDK, and like, you know, it's a developer, you're pretty technically savvy. You can like build your own blockchain, you can like pair together a bunch of stuff, right? You're like, oh, like I want this consensus mechanism, I want this virtual machine, I want, you know, like I want native data, like account abstraction, like stuff like that. Or I want like MEV recapture. And it becomes all the way easy where it's like so easy that like a lot of solutions are like, no, like we don't even need to like build developer tools. Like we're just going to like expose this as like a no code for like non-technical users. And then it becomes like that one click, right? You're like, click, 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 like 3 blockchains, please, you know? And so that's like basically what RaaS is essentially.
So is the idea that I would be able to not only create my own blockchain, which it sounds like I can already do today with one click, but I'll also be able to build my own apps on top of my blockchains that I create without having really like much technical skill?
Yeah, I would say so. So it's like, you know how like during like JPEG summer, there was all these like mint your own NFT collection like solutions, right? And it's like, oh, like just like upload some art and then like we'll like mint like Manifold's like a good example.
That's what
of
we
that,
use, Manifold.
right?
Yeah. Exactly.
Yeah. Manifold's great. There's also another one called like Pirate Ship, I think. I don't know. Just wanted to be unbiased with my recommendations. But you can kind of see it being like more like full stack now. It's like, oh, like, you know, before it was like make an NFT collection on Polygon, make an NFT collection on Ethereum. Now it's like make an NFT collection on your own blockchain, and like you want it to be like super cheap, like we're fine. Like you want it to be like really expensive, or you want it to interact with games on Ethereum, or you want to interact with IP on Ethereum or games on Solana or whatever, right? Like it becomes like a little like you get more kind of like agency and configurability kind of in that world.
Very cool. So you've been working on a new project recently called Catalyst, and Catalyst is a cross-chain liquidity layer for modular blockchains. Can you explain what that means?
Sure. Yeah. And so I think the best way to describe it is kind of along the through lines that we've been discussing. And so, you know, there's kind of the modular blockchain thesis that has made it, you know, easier and easier to make rollups or to make modular chains. so easy that there's all these projects that are basically like creating a out of the box solution or a full stack solution in order to have it run as a service, right? And so that kind of ties back into like my original thesis of saying like there's going to be millions of chains, because like I think everything will be a blockchain, every application will be its own blockchain, because it's just like so lightweight and configurable to do so. But I think in this world of which there are like millions of blockchains, like a lot of things break that we kind of have taken for granted. Like, what does like a block explorer look like in a world of like all these different blockchains? Like, how do you like index all this data? How are you able to like see the transactions happen not only within one blockchain, but also like spanning multiple blockchains, right? Like a cross-chain block explorer. So like that's like one thing that I think is super important. Catalyst is like kind of tackling, I think, another very, very important piece from an infrastructure perspective in this world of millions of blockchains. And that's essentially like the ability to move value between them, right? So it's like, what is the point of having millions of blockchains if they're all just kind of doing their own thing in their own corner of the universe? No, we need trade, right? We need some form of connectivity and value transfer between them. And so Catalyst is essentially that, right? You can think of it as like it's like a liquidity layer, right? It's moving value between all these different chains, and it's instrumented in a way that anytime a new chain is created, it automatically works with Catalyst, right? And so it's like you spin up a new chain, it can automatically connect to any other chain that you want, right? Whether it be like Ethereum or whether it be some other application-specific rollup, and then you can start moving value between them, right? And so we're really building for these like modular chain teams that are spinning up these modular chains and offering that out-of-the-box solution to connect to other chains.
Gotcha. So essentially, it's like a decentralized exchange, like how people use Uniswap today to trade crypto. People could use Catalyst in the future to essentially like trade between different blockchains.
Yeah, definitely. It's like could be like an exchange, could be like a bridge, so to speak, a token bridge. But yeah, we're just trying to like add liquidity into this like multi-chain world.
Gotcha. Cool. So at what stage in your building are you today with Catalyst? And like, can people go check it out, or are you, like recruiting devs, or like what stage are you guys at with building Catalyst?
Yeah, so it's not publicly available yet. We're still heads down building. But with that said, we do plan on releasing kind of various versions of Catalyst that people can use within the coming months, I would say, as well as some other updates on it. But right now it's like kind of just, we're just building it, and eventually we'll kind of have it in alpha, and then people can join the waitlist in order to test it. And then over time, we'll have kind of subsequent versions before it's live in production on mainnet.
Very cool. Very cool. All right. So as we're wrapping up, I've got some questions from our community on Twitter that they wanted to ask you. I'm going to cheat a little bit and start with a question I have for you. I know before starting Catalyst, you were running experiments at Aave. And you've also run a good number of personal experiments too. I think the earliest one I remember is Dumb Jimmy's. I don't know if there's anything before that, but I just remember that one very clearly. I'm curious to know, what are some of your most memorable experiments? Maybe like, do you have a favorite one? Do you have a least favorite one? Which one do you think was like the biggest success? However you want to define that. And which one would you say is like the biggest failure? However you want to define that.
Personally or at Aave?
Both. I mean, yeah, we can mix them up.
I'd probably say my most successful experiment was this one called Rememe, which is like rememe.lol if people want to check it out.
Yeah,
it's
I remember that
one. But just like, I guess for the audience, it's like an on-chain remixer. And so like you can post content, or like you can post like a meme template, and then people can remix it and like kind of add on top of it. And so that was like a really, really interesting one. There's been like a few other kind of projects that have kind of taken that and run with it over time. Like the concept of like just like remixing memes, and it's kind of like stemmed from the interest of like stitching or duetting like a TikTok video. And so we were trying to like do that on chain, so people can start seeing like the canonical like meme and like kind of the tree of remixes that kind of span from it. So that was like a pretty cool experiment on top of Lens. Yeah, that was the most successful one, I would say, from like a usage perspective. I would say my least successful one is probably, I tried to make a DAO to like acquire rare cool cats. This was like in summer 2021. I was like really into cool cats. I mean, I still have them. They're quite cool. But yeah, I was like really, really into it. And so I really wanted to acquire all these like one of one cool cats and like make like a DAO out of it. I think there was like some precedent with like maybe like CryptoPunks or Bored Apes or something. Like, you know, there's another kind of investment into the acquiring those. And so I was like garnering support. Like people were like, yeah, I'm super interested, super interested. Had like a Telegram group of like 50 people and like managed to gather like, I think like 10 ETH or something. And I was like, I don't think this is gonna even buy like one cool cat, let alone a rare one. So I was just like, nah, I think we're good. I think we're just gonna call it a day.
Nowadays, you could though. You could restart that. I think cool cats are pretty affordable today, aren't they?
Yeah, definitely. Yeah. With less fervor, unfortunately.
Yeah, I know. I was sad to see that. But pudgy penguins, though, on the other hand, we don't have to get into that.
It's true. Yeah.
Another question we have is from Meg Lister. She wants to know where you got the hat. It looks kind of like a safari/cowboy hat that you're wearing in this photo I posted on Twitter that was from our Everspace Camp trek. Do you know what I'm talking about?
Oh, yeah. The one where I look like a cowboy.
Yeah. Where she wants to know where you got that hat. 'Cause she wants one too.
I think I got it on like Amazon or something.
Okay, easy enough.
So I can share the link with Meg. But that was a good day because that was like our like first like truly sunny day, which was also like the last day of our hike.
It was not our first truly sunny day. So for context, Jimmy and I hiked Everspace Camp last fall. I would not say that was our first sunny day. I think we had some good weather after like day 3 or 4, maybe.
I don't remember.
You were just brain dead from the altitude after day 3.
Yeah.
But
it was like an objectively nice day.
It was.
Like
it was
really
our
nice. First nice day. Like there were days that weren't raining and we were like, this is a nice day. We're like, no, it's just not raining.
Yeah, and I think the fact that we were coming down from the mountain that day made it better too, because we were all in pretty good spirits. Was that our last day?
It was our last day.
Yeah.
Because we had lunch where we stayed the first night.
Yeah, that's where that photo was taken.
And then I almost got run over by an ox.
Yeah.
You weren't there for that, were you?
I think I was.
Because you were in the front? Yeah.
I was in the back.
Okay, you weren't there, but this woman saved my life. It was crazy.
Oh, wow.
Like she was like on this ledge, like above the ox, and like I was like about to get hit, and then she like pulled me, like she like held me by my arm. She was like so strong, like as the ox was like going by.
Wow, Ox Jim getting trampled by an ox. That would have been quite the headline.
Yeah, very poetic.
Yeah, I'm glad it didn't happen. Meg also has a more serious question. She wants to know what kind of consumer apps are just waiting for the ideal bridge solution or catalyst in order to thrive?
So I would say when you look at apps that are creating their own blockchains right now, they're like pretty standalone experiences. And so I actually wrote about this in a blog post I posted like last week. But like it's basically like it's like standalone DeFi applications. So like things like derivatives trading or like structured products come to mind. The second thing is like video games, right? And then the last thing is essentially like a catch-all. It's like creator economy / Web3 social. So all those things are like apps that can kind of just like run on their own. But there are a lot of apps that kind of benefit from the composability and the interactions of like other applications, right? So something like Aave is a great example where it's like Aave is great as standalone, but like it becomes a superpower once you add things on top of it, like Morpho, like Alchemex, like Barnbridge and stuff like that. Kind of just like the money Legos kind of narrative that we saw really take off in 2020. And so I think all those applications are kind of like waiting in the wings, being like, I need this like composability, or even said differently, they're like, I would like to launch on a chain, but like all my users live on Ethereum and like I don't even know how they can like move money or like move data into this new chain without some sort of like bridge solution. And we're building precisely for that use case.
Nice. Another question we have is from Grocer. They want to know, what are your thoughts on ordinals?
Ordinals, I think, are like not super interesting from like a technical perspective, right? It's just like, okay, like you're just, using this like blob format as a form of like metadata. And it's actually funny, like that's where like the meme, like Bitcoin as a data availability layer comes from as well. But I think it's cool because it's like, it kind of, it gives Bitcoin like a reason why people want to use it. Because it's always been like an existential thing about Bitcoin. It's like, okay, like if you're a store of value, that means people aren't really sending, like they're not really using the actual network. And they're not using the actual network. Like why are miners even like securing the network, like even like mining these blocks? right? It's like, because eventually like the block reward is going to be like so low that like people just aren't going to mine it anymore because they need actual transaction volumes to pay for like those operations. And so now like Ordinals came and it's like, oh cool, like now like usage in Bitcoin's up, and at least we stave away that like existential fear for like maybe like a year or two.
All right. Last one from Twitter. David Phelps wants to know, what's that one sample you use in every DJ set? So Jimmy is he's a DJ at night ish, wouldn't you say?
In the morning.
Yeah, early morning. Well, early morning hours and late night hours. He's a DJ. So what is David seems to think that you know what he's talking about. What is that one sample you use in every DJ set?
Yeah, I have no idea what he's talking about. Like, honestly, nothing comes to mind. I like to think that I don't repeat myself ever, you know, because I have such a depth of musical knowledge that I never replay the same thing. No, but realistically, like, I think I shared a link on Twitter. I was like, is it this? Like, he never responded to me. So my answer to you, David, is respond to my tweet.
Let's take this offline.
Yeah.
Onto Twitter. Okay, so last thing we do every episode is we play a game. This season we're playing the word association game. I've got this tin here of about 50 slips of paper. Each piece of paper has a word on it that is a word that's commonly misused or overused in Web3. So I'm going to draw 10 of these at random, and I'm going to say, read the word, and you're going to say the first word that comes to mind. Okay? So Only rules, you can't repeat the word I just said, and you can't respond with the same word all 10 times.
Okay.
So first one, scarcity.
Economics.
Ownership.
DAOs.
Scalable.
Rollups.
Incentive.
Airdrops.
Creator economy.
Packy McCormick.
Inflationary.
Olympus.
Reputation.
Reputation. Oh, fuck, I already said DAOs. Unstoppable domains.
Okay. Decentralization.
Solana.
Ownership economy.
Legion from Variant.
Substrate.
Polkadot.
I like how you just resorted. That's it. I like how you just resorted to like proper nouns at the end of it. Like just say the name of the first company or person you think of when you think of that word. It's a good strategy. Everybody has their own. Hey, some people just like say the first word they see in front of them, like light bulb, water bottle, hat.
I could have done that. We can redo it if you want.
No, it's cool. We need to know the true you, and this is the true you. Last thing, Jimmy, before you go, tell people where they can find you if they want to follow you, keep up with your thoughts, and where people can go to learn more about Catalyst as well.
Sure. So I'm on Twitter. So feel free to reach out to me on Twitter. You know, if you were interested at all about the random kind of technical things that I was spewing in the past hour. I'm at 0xGym, or Diana calls me OxGym, but it's a 0. It's not an O. It's more of like a homophone of sorts. And if you want to learn about Catalyst, we also have a Twitter. It's Catalyst AMM on Twitter, and then you can also go to our website, which is catalabs.org, to learn more. And we'll be posting more announcements in the coming weeks.
Amazing. Be sure to keep up with all of that. Thank you for taking the time to come on the podcast. Thank you, everybody, for tuning in. And we'll be back again next Thursday with another episode of Rehash.
Thank you for tuning in to this episode of Rehash. Rehash is hosted by Diana Chen, produced and edited by Ellie Dots and Tyler Internet, and sponsored by Lens, Empire Wallet, and NFT.storage. Rehash is also supported by Rehash DAO, a community of NFT holders who curate our guest lineup each season. To get involved, head over to our website at rehashweb3.xyz and collect this episode as an NFT. Anyone who collects an episode becomes a part of Rehash DAO and will be able to nominate guests for future seasons. Voting rights are reserved for our guests, sponsors, and OG crowdfund supporters. And to learn more about how to become a guest or sponsor, go to rehashweb3.xyz/podcast. Finally, be sure to follow us on Twitter, Instagram, YouTube, and TikTok at RehashWeb3, or on Lens at rehash.lens.